Okay, so we're going to talk about how do you identify the direction of a vector. Now, so far you've learned that what makes a vector unique is that a vector has direction, right? So it has both what we call the magnitude, or the how much.
Vector, is that a minus or equals? Or it's just a dash? I mean,
It
like,
is.
well, is it supposed to represent a minus?
No.
Dash. Thank you.
Right? So vector has both magnitude and direction. So far we've talked about how to find the magnitude. Right? If we have, say, a path of 5 meters north, and we add to that 3 meters south, then the distance that we traveled was, good, 8 meters, and the displacement of our trip was 2 meters north, right? And I could have done that graphically by showing the 5 meters north plus the 3 meters south, and then the resultant, right, the sum of those two would be from where I started to where I ended, and you can see that's clearly 2 meters in the north direction. How is that not clearly? It says it right there. Oh, fine. Anyway, so this, right, is the magnitude, and north in this case is the direction, which is really straightforward when I just go north and south. But as you found last time, if we do something like this, let's say we're going 7 meters north plus, let's say, 4 meters east, then if I draw that, I've got 7 meters north and then 4 meters east. Then the resultant, right, the sum of those two from where I started to where I finished. The magnitude we've already talked about, right? How do I find that? Yes, it's square root of 65, right? Which is basically 8, practically 8. So the magnitude's easy. But what about the direction? Now, up to this point, what have we said? Northeast-ish, right? To say that we know it's not really northeast because that would be halfway. But northeast-ish doesn't sound very precise or scientific or technical, does it? So we're not going to do that. We're going to determine exactly what the direction is. So how we're going to do that is first, here's the vector, right? This is the one we're wanting to label. If I knew this angle right here, call it theta, would that help me describe the direction of that vector? Yes. Yes, it would. And how, pray tell, could I find that angle? Good. I could use sine, cosine, or tangent. Now, I don't care which of those three you use. I'm not going to penalize you for using one over the other. But just to be clear, if we wanted to be most precise, which function should we use? Tan, right? Why?
Because they're 4 meters and 7 meters exactly.
Good. 4 and 7 were given, right? I rounded the 8. So tan would be the most precise, but again, I'm not going to penalize you for using another one. So I know that tan theta equals 4 over 7, right? Opposite over adjacent. And just a quick calculator review, if I don't know the angle, if I'm looking for the angle, that's when I'm going to use the inverse function of tan of the quantity 4 divided by 7. And when I do that, I get theta is an angle of, call it 30 degrees.
It's just combined. possible pre-calculus. Yeah, seriously.
Absolutely.
You can see it.
Calculus was
I was not.
invented because of physics, so that makes perfect sense. All right. Now, so I know, for example, that this angle is 30 degrees. So one way I could name this vector, the direction of this vector, is I could say it is 30 degrees east of north. Right? Because here's north. I know that this 7 meters was due north, and this is bent over 30 degrees away from north towards the east. So I could call it 30 degrees east of north. But that's the same thing as 60 degrees north of east, and plus it just kind of gets a little confusing. So here's what we're going to do. Don't groan. We're going to use the unit circle. I said don't groan. Alright? We're going to use degrees instead of radians. So, which that brings up a good point, right? When you're in this class, almost always, all year, you're going to be in degree mode. So if you go into pre-cal and switch to radian mode, make sure when you come back in here you switch to degree mode before you start punching this in. If you get some weird number for an angle or otherwise, then check your mode. And this is also 360, right? Okay, so watch what we do. We're going to take this vector we just made, or just identified, and we are literally going to imagine putting it on the unit circle. What quadrant is it in? It's in the first. So I'm going to name its direction, and I know if it's in the first quadrant, it's going to be between 0 and 90. Now, where is it? What would that be? 60 degrees, right? If this is 0, and I went to 90, and I know it's 30 this way of 90, then that makes it 60 degrees. So my final answer for this vector is 8 meters at 60 degrees. That's how I name that vector. Because here's the vector, right? And so I'm going to start at 0 and go this way, just like we do in the unit circle. And so if I go from here to the vector, how far did I go? If I had kept going to 90, right, I would have gone this much farther. Well, how much was this much? 30, right? So this must be the 90 minus that 30. Does that make sense? We're going to do more practice if it's not perfectly clear yet. All right, what about this one? I would love for you to add, say, 9 meters south plus, say, 6 meters west. See if you can do that. Remember, always put HUDs on your arrows so you can tell which direction they're pointing.
E. So if you put up there what quadrant? You hit by chance. You hit by chance. We hit by chance. You hit by chance. We know you hit by chance. Good. 270, right? No. 236. No, yeah, you go from 270. 236. Why do you go from 270? Oh, you always go from the top one because you went from 90. No, because that would make sense. Bye.
Alright, so let's look at this.
That was cool. She dropped the thing and went out the door and she opened up the door to get it. I thought that was cool.
Very cool. Alright, so 9 meters south, and then 6 meters west. That means the resultant started here and went to there. And by the way, I didn't see anybody make this mistake this time, but it's really common. Be careful not to do this. Don't go 9 meters south plus 6 meters west like that, because that's not tail to tip. And just imagine yourself walking. Say, can I walk from here to there and then add to that going from here to there? No. So always tail to tip. Alright. Then the PFAG tells me that's about 11 meters, right? 10.8, 11 meters. But now I've got to get the directions. So this is the resultant, right? So I want the angle that touches the tail of that vector, which is right there. And by trig, I find that that's 34 degrees, right? I put it over on that unit circle, and if I put that tail at that origin, which quadrant is that in? It's in the third quadrant. And which angle do I know? Do I know this angle, or do I know that angle?
Oh, I get it now.
Well, but which one is 34? This or that? This. Thank you. This is 30. That's why I say this and that, because you can respond and I know which one you're talking about. This angle is 34 degrees. So I can either take the 270 and subtract the 34, or I can find that angle based on what this angle was, which gives me 56 degrees, and do what to it? Add it to 180. Either way, I'm going to get 236 degrees. So the Correct answer is 11 meters at 236 degrees. Okay? Alright, one more. Last one. What if I went...
Do a big number. No, because then we'd have to square that.
121 meters. Let's go south plus 78 meters west plus 24 meters north.
Okay. You went in exactly that order?
Good question. Does it matter?
Yes.
Remember our F3M from yesterday?
Yes, it does. So did you go in that exact order?
It actually won't change the displacement.
It won't.
Same answer. Yeah. I'll go different paths, right? I'll step on different frogs depending on which way I go. But where I end up will not change based on where I'm going. As long as I keep direction.
Oh.
So, if I take the 121 south, and then I go 78 west. That's right. Good catch, good catch. And then north 24. There's the resultant, right? From where I started to where I finished. That's the guy we're after. Now, it's not part of a triangle right now, is it? It's not very pretty. But if I do this, then there's a triangle, right? A right triangle. This is 78, and this is 121 minus 24, which is 97. So now I do have a triangle that I can deal with. I do Pythag, and I get 124 for the magnitude.
What?
Pythag.
Oh,
And then if I do trig, I get, what's this angle? What's this angle?
39 degrees.
That sounds right. 39 degrees. So, it's in the third quadrant again. I know this angle is 39, so I go to 270 and come back 39. I get a direction of 231 degrees. So my final answer is 124 meters at 231 degrees. $231. All right?